So in this video I'm going to derive equations of motion first by normal ordinary definition based method uh, derivation by using definitions by using okay. So for first equation we know that acceleration a is equal to uh, change in velocity, that is v minus u divided by time. So quite obvious. And see, one more thing I want to say here, that it is for uniformly accelerated motion only, not for any kind of motion, for uniformly accelerated motion only. So whenever there is a question, a numerical based problem or any other problem, you don't go blindly for equation of motion every time. Just think, just see whether it is the case of uniform acceleration or not. If not, you can't use it. So now we will cross multiply it, at equal to v minus u, and hence v equal to u plus at. In the same way, second equation will derive by using the fact that displacement is equal to velocity multiplied by time. Now remember one thing, uh, because it is a case of uniform acceleration, so velocity will be not constant. It will change from initial to final. It will vary. So in the place of velocity we will take average velocity. And how are we going to find average velocity? Is it displacement upon time? Yes, of course, but it is also displacement s equal to average velocity v plus u divided by 2 multiplied by time. Is it always true? Yes, for uniform accelerated motion, and no for any other case. So remember that for uniformly accelerated motion you can find average velocity by displacement upon time, as well as for u plus v divided by 2. All right, now from equation 1, from first equation of motion, we can replace the value here. So s equal to, in the place of v, I'm using different color so that you can see this value of v. We are putting its value by using first equation of motion, u plus at plus u, this is this u, multiplied by t divided by 2. So it will be 2u divided by 2, we can say it like this, and at divided by 2 multiplied by t. So finally it will be 2 will get cancelled, t will be multiplied inside, ut plus half at squared. Here it is. And for third equation we'll again follow the same pattern, this, in fact this, but here we are from first equation of motion we know v equal to u plus at, but from here we can find t in terms of v minus u by a, and we can directly put it here. So s is equal to v plus u by a multiplied by v minus u, oh sorry, by 2. Oh, and so now it's quite easy. 2as is equal to v square minus u square. You can further change it, v square equal to u square plus 2as. Next is graphical method. That's quite nice method, and this will give us an insight of the graphically what else we can find. So now there is graphical method. Why is it important? Because by using this we are able to understand the graphical how to use graphs. Okay, so there is velocity, there is time, and let us suppose there is u and there is v and there is t. Okay, uh, this point is A, B, C, C, D, and this is O already, O. So now S is equal to, we know for VT graph S is equal to area below VT graph. I'm not writing further, bounded by time axis. That's important. Area below VT graph bounded by time axis. So actually we should say more precisely area bounded by VT graph line and time axis. That's much better. But in general we can say it like this. It is less bulky and more understandable. Okay, now there is a rectangle and a triangle. So area of this rectangle, length into breadth, I am going for breadth into length. So breadth is OA into length OD plus half into base into height. So I am considering it as height BCB, no problem, into base AC. Okay, so OA is actually, value of OA is U multiplied by, just replace this multiply sign, we can directly write it. So OD is actually T, so UT it is, plus half CB. CB is neither V nor U. Actually it is V minus U. So it is V minus U, and AC is T. That's all. What I am doing. Uh, I'm deriving actually second, then third. I just forgot because of the previous derivation. So anyway, it happens. So it is from first equation of motion, uh, V equal to U plus AT, we can write V minus U as AT. So you can write down this, that from first equation of motion, V minus U is equal to AT. So I'm putting AT here multiplied by T. So it is UT plus half AT squared. That's all. This is what the outcome of this expression is. Next, if I have derived a second equation here, then I'm deriving here third equation, then we'll go for first. So again, we will copy entire thing here, this one also, and here I'm opening this bracket. So it is UT plus half VT minus half UT. So 1 UT minus half UT, that is plus half UT. So plus half Okay, I'm writing Vt first and then plus half ut. It is quite understandable. I don't think there is any problem with it. So if I take half uh, common and t also, then it will look like this. And now from the same equation, first equation, we can do, we can find t equal to v minus u by a. We can put it here. So v plus u, v minus u by a. This is s. Now 2a will get multiplied there. So 2as is equal to v plus u, v minus u. So it is v square minus u square. And that's all. Finally, we can write v square equal to u square plus 2as. And for first equation, that's so easy. We know from Vt graph we can find acceleration. So a equal to slope of Vt graph. Where is that Vt graph? There it is. Oh, that's not what I want. This is what I want. Where is it? Here it is. So slope of Vt graph perpendicular upon base. Remember what is perpendicular here. This BC is perpendicular. AC is base. So it is BC by AC. BC is V minus U by T, and that's all. That's all. It will be AT equal to V minus U. So V equal to U plus AT. That's all. And now the most awaited calculus method. Okay. So first equation, once again, we will start with the same idea that A is equal to dv by dt. This time we are using calculus. Now derivation mode is for calculus, equation of motion by calculus method. Equation of motion by calculus method. Alright, so A equal to dv by dt. If we cross multiply it, then dv is equal to a dt. And then we will integrate. Oh god, what a silly mistake. Great. Both sides. dv equal to integration a dt. Any variable can be integrated. So here dv, v variable is integrated, and here t variable is integrated. Let me remind you, I've already told you about this formula, integration of some t to the power n dt is equal to t to the power n plus 1 by n plus 1 with of course some constant of integration. This formula is we are going to use, and if power is 0, then it will be t to the power 1 by 1, or we can say t to the power 0 means 1, that is integration of dt means t plus some constant. Yes, of course, but we are more interested in this. Okay. Oh god. Well, now why I'm not bothering about constant, because I'm going to take limit, and as I told you, when we take limit of integration, then there's no need for that constant to be put after integration. So here limit of integration, why velocity, actually because velocity starts from u, so limit starts from u to v, and here time, limit starts from 0 to t. So integration of dt is t, so integration of dv is v. Here also, see, a is a constant. Why a is a constant? Because these equations are applicable for constant acceleration case only. So a is a constant, so only the integration will take place for dt. So that is t limit 0 to t, a of course outside. So it will be, see, whatever be the limit here, let us suppose if there is x and there is y, then first we will replace this v by then minus this y. But here uh, first we will replace this v by this v, which sounds weird, but and then this v by this u, a, this t by this t, and then, and that's all. This is what first equation of motion is. But if we want some more complication into it, so maybe there will be limit of integration if initial time is not 0, it is something else, then it will be if initial time is t equal to t naught or something else, t1, whatever we can say. I mean, initial time is t naught, to avoid confusion. Then what will happen? This is equal to a integration t naught t dt. Then its end will be, I'm directly putting the uh, integration limit after solving it, that that will be u v minus u, and that will be a t minus t 0. So this will be the answer. This is a modified form. So we should just keep this thing in our mind also, because such type of form can be asked in the exam. They can give such forms in the exams, or we have to find certain values in this form. So moving on, second equation. For second equation, we need this expression, v equal to ds by dt. So ds is equal to v dt, and in the place of v we will put u plus at, then dt, and then it will become ds equal to u dt plus at dt. Remember, I remind you again, again, acceleration is constant. This is applicable for constant acceleration only. Here u is also constant because initial velocity will never change. Okay, now integrating both sides. So I'm directly taking constant part outside. Okay, now limit of integration s 0 to s. 0 to t, 0 to t. Now, as I told you, dt, integration of dt is t plus some constant, but we don't bother about it because of limit of integration. So ds is just s, limit of integration 0 to s. U dt integration t, 0 to t, plus a. Here, as I told you, t to the power n dt integration is t to the power n by n plus 1 by n plus 1. So same thing we are going to use here. Okay. So using that, it will be t square by 2, 0 to t. Again and again and again, recalling that formula, it's better to just, you know, mm, practice is so well that whenever you see such type of problem, you can directly write its answer. Okay, so here limit of integration will be put, that will be s minus 0 is equal to u t minus 0 plus a t square by 2 minus 0. So that will be s equal to ut plus half at square. There it is. Other than that, again the same derivation can also be done if initial position is not 0. It is possible that originally the position of that object is something else other than 0. Then how will this will get modified? So let me tell you, for modified values, if initial position is s naught, then it will be integration s naught to s ds, that is equal to u dt 0 to t plus a t dt 0 to t. And what will be the answer? This part will be remain same, so I'm not changing it, but that part will become s minus s naught, that is ut plus half at square. Discussion doesn't over here. There is a worst condition in which initial time is not 0. That comes with the third case. So in such a case, again, if initial position is s naught and initial time is t naught, it is not 0, but with reference to some other time frame it is t0. Maybe 0 time instant is somewhere way behind, so we have selected this t0 as uh, our as the time instant of our point of observation. Then it will be s naught to s ds equal to u t0 to t dt plus uh, a t dt t0 to t, and hence it will be s minus s0, and that will be u t minus t0, and that will be a, because its integration will be t square by 2, so 2 is there, and it will be t minus sorry uh, t square minus t0 square. Why is it so? Because formula will be t square by 2 and limit of integration is 0 to t. Upon 2 will be taken outside, so it will be t square minus t0 square. This is how it is going to be modified. Okay. Now that's the worst case, and there will be nothing more than that. So now moving on, third equation of motion. So as we know, third equation of motion also start in both the cases. Third equation of motion was similar to second equation of motion. Here also we'll start from this point, v equal to ds by dt. But as we know, in third equation there is time is eliminated. So what we can do, see, there is a very deep discussion why is it so. But as again, I would say that maths have gifted us this type of mathematical operation uh, are valid. Is quite uh, but directly we are using it. T, I mean, because dv by dt is a, so we can write v equal to a ds by dv. Cross multiply v dv is equal to a ds. dv equal to a ds u2v. So v dv, v dv, again the formula t to the power n dt, just replace that t by v, that n by 2, so it will be v square by 2, limit of integration u to v, and here it is quite easy, s, limit of integration 0 to s. Next, v square by 2 minus u square by 2 equal to a s minus 0. So v square minus u square by 2 equal to as, v square minus u square equal to 2as, and that's all. And other than that, that another case in which initial position is s naught, what if initial position, no, v dv u to v a s naught to s, v square by 2 minus u square by 2 minus s naught. Video we are going to use these equations of motion.